Okay, everyone, I'm back. Okay, now I've got 15 minutes to do each video. I found out the hard way. So, just coming on back. So, last time we mentioned how, like, the square root of 2 is irrational, and most square roots cannot be simplified nicely, unfortunately. Now, R is called the real numbers. It is the set that consists of all rationals and the irrationals. So if you could put the rationals and irrationals together in the same house, you get the real numbers, the set of real numbers. And remember, the rationals are the things that can be written as integers over integers. Okay. The only stipulation being you can't put 0 on the denominator for the rationals. Now, note some irrationals have a predictable decimal. Now, just because they're irrational, that doesn't stop predictability. Note that numbers such as 0.27, 277, 2 2 quadruple 7, 2 pentuple 7, notice I'm smacking on another 7 each time. That is predictable, but it's not rational. So just to let y'all know that. So, that's not rational. Now, let's talk about negatives and exponents. And, well, one more thing. I'm going to talk about sort of what I call closure. If you multiply or divide or add any rationals, you'll get another rational back. Of course, don't divide by 0 or you're undefined. But anyway. However, if you multiply or add irrationals, you don't know what you'll get. You could get another irrational or you could get a rational. You don't know. So you don't have closure, unfortunately. But let's move along and let's talk about, I'm 2 minutes in. So let us talk about minus signs. So if we talk about minus signs just for a little bit, what do we got? Like if you have negative 8, you can write that as negative 8 over 1. You can write that as with the minus sign out to the side right here where my cursor is. You can also put the minus sign up here with the numerator 8. Or you could put the minus sign down here with the understood 1 on the denominator and have negative 1 on the denominator down here where my cursor is. So just watch out for that. Now with negative 7/3, you could have the negative out to the side. You could have the negative up there with the 7 or down there with the 3. So just watch out for that. So let's talk about exponents. We define anything to the 0 power to be 1. So we define, for example, why it's done that. If you raise anybody to the 0 power, you'll get 1. With the exception for that x does not equal 0, we leave 0 to the 0 undefined. Okay. So 0 to the 0 is undefined, but anybody else for x not equal to 0, we define it to be 1. It's because it makes everything work out really nice. It's consistent. I won't go into all the nice reasons why. You all will probably take it. Some of y'all will take advanced math later, and I don't want to go too deep in, but it causes consistency. It makes everything nice and consistent. For example, if you have 5 to the 0, you'll get 1. If you have 6/5 to the 0 power, you'll get 1. If you have negative 2, you got to use parentheses with negatives. If you power at all, you need the parenthesis, but you'll get 1. And let me space these out a little bit, like that. So 5 to the 0 power equals 1. 6/5 and it's nice to have parentheses here too, to be honest. To the 0 power equals 1, and parentheses negative 2 and put the 0 power outside the parentheses equals 1. You need those parentheses. So we define the 0 power to be 1 it keeps things consistent. Now, again, it should be noted that we leave 0 to the 0 power undefined. That's the one exception. Now, and it should be noted that you can never divide by 0. And indeed, even if you have, we don't define 0 over 0 either. So, let's give it, so things like, I'm 6 minutes in, 0 over 0 is undefined. It does not, don't set it equal to 1, it's not. 1 over 0 is undefined. We can't use infinity or something, so that's undefined. We leave all that undefined. All these things are undefined. We don't want to mess with them. Anyway, so these are the bad things, right? And anything over 0 is undefined, right? We don't want to ever put 0 on the bottom, right? And we don't want 0 to the 0 because it's vague. We don't like it either. Now, let's move along. So if I give that a title, so there's exponents, and this is just a little this is undefined things. But let me get back to exponents, okay? So back to exponents we go, and I'm almost halfway in, but I've got a little time. I have to do video by video. If I do, let's see. Well, look, now we define the 1 power to just be the identity. So like x to the 1, now that equals x for all x. Anything, you can let x be 0 and be fine here. So for example, parentheses neg 5 to the 1 equals neg 5. Excuse me there. 7 to the 1 equals 7. Sorry. And let me do a fraction. And then let me scroll down. If I do 2/3, I gotta scroll down. So if I do 2/3 to the 1 power, it's 2/3. So the 1 power is just the identity. And we define it that way because it's very, very consistent as well. Now reciprocity, negative powers, and I don't mean that like they necessarily like they mean that like maybe a mechanics place. Negative powers, how about I just say reciprocal? Or I don't mean that like they do in the business world or something. Reciprocal. So, like, here's how we define the negative 1 power. If you have something like the reciprocal of 3/2, if you raise that to the negative 1, we define the negative 1 power to be the straight-on reciprocal, 2/3. It works out real consistent with the rules that we're going to define later. And let me just copy this and paste this so I won't have to go back to editor a lot. If I do something like, let's say I have if I do negative 3/2 to the negative 1, well, the reciprocal of a negative is just another negative, so the reciprocal of negative 3/2 is negative 2/3. Okay. Now, there's only one number that does not have a reciprocal. Now, 0, you remember we said we couldn't divide by 0? So 0 has no reciprocal, so 0 to the negative 1 is undefined. We cannot take the reciprocal of 0, right? So we can't do 0 to the negative 1 power. 0 cannot be raised to the negative 1 power. 0 cannot be raised to the negative 1 power. Everybody else can, though. Any other real number under the sun can be. Right? It's just, it'll be the reciprocal of that real number. That non-zero real number. Well, if I'm about to run out of time if I'm not careful. So now from that, let's do the square power. What does it mean to the positive 2 power? It just means to multiply 2 times. Like if you have 7 to the 2 power, that would be 7 times 7. That means you multiply it 2 times, and that's 49. And here's how we handle the negative 2 power. If I did 7 to the power of negative 2, that would be, what I would do is I would do 1 over 7 times 7, and that would be 1 over 49. So it just takes the reciprocal, like that. In particular, it's 1 over 7 squared. I need to highlight that. I'm correct, but I need to highlight a main point here, right? It's nothing wrong. I just need to mention what needs mentioned. 7 to the negative 2 is 1 over 7 to the positive 2. You're doing 1 over the positive power. So 7 to the negative 2 power is 1 over 7 to the positive 2 power. I've got 3 minutes and I'm in a rush. But if I do like 5 to the power of 2, that's 5 times 5, which is 25, right? So it's, and it's going to hold that. Let me copy this or I'm going to have to go back. If I raise 5 to the power of negative 2, I'm going to run out of time. 5 to the negative 2 power is 1 over 5 to the positive 2 power. So it's 1 over 5 times 5. So that's going to be 1 over, 5 times 5 is 20 down here, is 25 down here. So it's the reciprocal, right? 1 over 25. That's how you do negative powers. So that opens up a big door. And I'm down to my last 2 minutes. But you can do fractions. Like if I had, let's say I had 3/7 to the 2 power. Well, that's going to be 3, I don't know if I can do this in time, 3/7 times 3/7. Well, remember by the law of fractions, you multiply top times top and bottom times bottom. 3 times 3 is 9. 7 times 7 is 49. And I'm playing dangerously, about to run out of time. But let's try it. Let me try one more thing, and then I'll have to stop this video and resume on the next video. But 3/7 to the negative 2. Well, now, 1 over would be awful sloppy here. Awfully sloppy. So, well, what do we do? How do we write this? I can't have this anymore. I want to turn that into the positive 2 power real badly. So what I need to do is just turn it upside down, the reciprocal. So it's 7/3 to the positive 2. I changed negative 2 to positive 2, and I turn this upside down to 7/3. So I just, that's going to be 7/3 squared. And, that's, I multiply 7/3 by itself twice. 7/3 here. So 7/3 here. And, that's 49. 7 times 7 is 49. 3 times 3 is 9. And lo and behold, reciprocals, right? 9 over 49 is the reciprocal of 49 over 9, and vice versa, right? Reciprocal is a mutual relationship. Thank you, everybody. We'll resume on the next video.